Namaskar, a assistant professor in the chemical engineering department of LGIT Ahmedabad. In this lecture, I am going to start new topic of the mass transfer operation 1. So let's start. Chapter name is Leaching and topic is basics of the leaching. In last lecture, I have explained you related to the leaching. After that, we have also seen the factors affecting the rate of the leaching. Now in this lecture, we are going to see some basics of the leaching. So you can see on the screen, this is the definition for the leaching. So according to definition, the separation of a solute constituent from a solid by means of the solvent is known as the leaching. Yesterday I told you, if you want to extract some constituent or some solute from the solid by using liquid, then that separation process is nothing but leaching. But if you want to extract some liquid part from the liquid solution by using another liquid, then that process is known as the LLE, or I can say liquid extraction. So this is the difference between leaching and liquid extraction. In leaching, we are removing one of the part from the solid by using liquid, but in LLE, we are extracting one of the liquids part from the liquid solution. Now we will see some important steps involved in the leaching process. So you can see here, first step is contacting our solid with the extracting solvent. So according to first step, you can see here, contacting the solid with the selective solvent, the liquid, in order to dissolve the soluble solute in the solvent. What is the meaning of this? Means if you want to extract some component from the solid, or if you want to extract some solute particle from the solid, you are going to contact that whole solid with the extracting solvent. Okay, so this is the first step. After that, you can see here, separation of the insoluble phases. Insoluble phases means we are going to contact, listen carefully, we are going to contact our solid, whole solid with the extracting solvent, and extracting solvent is removing only soluble part of the insoluble solid. Means whole solid is nothing but one solid, okay, one particle, and we are removing some part of that particle, okay, from that solid by using extracting solvent. Remaining part is nothing but, remaining part of that solid is nothing but your insoluble. So that is nothing but insoluble part of the solid. So you can see here, second step, separation of the insoluble phases, i.e. separation of the liquid phase from the solid physically by settling, filtration or any mechanical operation. Means we are extracting some solute particle from the solid by using liquid, okay. That is nothing but overflow. I will explain you what is the meaning of overflow and underflow, but just listen here. If I am extracting some solute particle from the solid by using liquid, okay, so that liquid taking away some solute particle from that solid, that is nothing but overflow, okay, and remaining part of that solid, that is nothing but insoluble, and that remaining part also having some solvent, okay, so that is nothing but separation of the insoluble, where we are separating the solid particle, that is insoluble solid particle, from the solution, or I can say from the solvent, extracting solvent. Okay, so these are the two steps I am repeating. In leaching, we are extracting some components from the solid by using extracting solvent. Okay, so in first step, we are just contacting our whole solid with the solvent. Okay, and in second step, whatever the remaining part of the solid, that is insoluble with that solvent, that whole is nothing but insoluble. Okay, that whole solid which is insoluble in that solvent is known as the insoluble, and we are separating that insoluble from the remaining solution or remaining solvent. So that is nothing but your second step. So separation of the insoluble phases, separation of the liquid phase from the solid physically by settling, filtration or any mechanical operation. Okay, so we have separated here two streams. First one is our solid particle in that solvent, and second one is our insoluble part. After that, we have also separate our insoluble part from the solution in second step. Now first step, in first step we are getting some solid particle in our solvent. So what is the function of that? Now you can see here. So whatever our requirement, that is the clear solution, or I can say overflow, you can see here, in normal operation, the stream leaving the second step, that is first one is the liquid phase. Okay, liquid phase means a clear solution of the solute in solvent. Means whatever the solvent, extracting solvent is extracting that solute particle is present in that solvent, that whole solution is nothing but clear solution, that is known as the overflow. You can see here, or I can say strong solution or leach solution. So this is your requirement, where you are getting two streams First one is your overflow and second one is your underflow. So overflow, that steam is nothing but your requirement where you are extracting some valuable part of the solid in your liquids. Okay, so first one is the liquid phase where a clear solution of the solute which we want to remove from the solid particle present in the solvent, that is nothing but overflow, and overflow is your requirement in a leaching process. Now second one you can see underflow. So what is the meaning of underflow? You can see here. So remaining part of the solid, that is nothing but slurry or wet solid. Wet solid means insoluble part of the solid having some part of the solvent. This is the insoluble part of the solid and that is nothing but waste, or I can say that is not our requirement. Our requirement is overflow, that is the leach solution. Okay, and this is your slurry or wet solid consists of the solid and some part of the solvent, that is nothing but your underflow. Okay, so these are the very important terms. First one is the overflow and underflow. Overflow is nothing but your leach solution or strong solution, means whatever the solute which you want to remove from that solid by using that liquid, that is nothing but your overflow. And whatever is the insoluble part of that solid present in the solvent, that is nothing but wet solid. Wet solid means solid having some liquid part as well of that extracting solvent. So this whole material is nothing but insoluble, or I can say that is the wet solid. And this flow is nothing but your underflow, or I can say leached solution. Okay, so overflow is your main stream and other stream is nothing but your underflow. Now we will see heap leaching. Okay, so this is also one type of the leaching. You can see here, this is the definition of the leaching and this is the figure for the leaching. So what is the meaning of the heap leaching? Before that you should know the meaning of the leaching. So I already told you in previous lecture and in previous slide as well. In leaching we are extracting part from the solid by using liquid. Okay, but here heap leaching is present. So heap is nothing but layers, means here we are extracting some part from the ores, means here we are extracting metals from its ores. Okay, in the form of the heaps, in the form of the layers. You can see on this figure. Okay, there are heap are present. Okay, heaps are present. First one is the means there are different layers of your metal are present. So this is nothing but heap, and this leaching process is nothing but heap leaching. This question can be asked for 3 marks. What is the meaning of heap leaching? So heap leaching, listen carefully. Heap leaching is nothing but it is a one type of the leaching where we are extracting solute particle from the solid in the form of the heaps, or I can say in the form of the layers. Okay, so this is nothing but, and generally this is used in the extracting of the metal from its ore. So you can see on the screen, it is an industrial mining process used to extract precious metals such as copper, uranium or other compounds from its ores using a series of the chemical reactions that absorbs specific minerals. Specific minerals means whatever your requirement from that ore, that is absorbing. Okay, so this is nothing but heap leaching. So I am repeating, heap leaching is nothing but leaching, but here we are extracting metal from its ores in the form of the layers, or I can say heaps. Okay, so this question can be asked for the 3 marks only. Now we will see some nomenclature involved in the leaching process. So I am considering here 3 component system. Okay, so you can see here nomenclature. According to nomenclature, you can see here first component is nothing but pure solvent, or I can say that is the component A, means pure solvent, that is nothing but extracting solvent which you are using to extract some solid particle from the solids. That is your pure solvent, or I can say component A. Initially its composition is 0 because we are taking that in the pure form. So solute present initially in that pure solvent, that mole fraction of that solute in this pure solvent is equal to 0. Okay, whenever I am saying pure solvent means initially presence of that solute in that pure solvent is 0. Okay. Second one is the insoluble solid. What is the meaning of insoluble solid? We are going to treat solid with the solvent. Okay, means we are extracting some part from the solid by using this solvent. So whatever the remaining part, means whatever the part of the solid that is insoluble with that solvent, okay, insoluble with that solvent, that is nothing but your insoluble solid. Okay, we are extracting some soluble part from that solid by using this liquid. that is the soluble solid part, but remaining part, that is the insoluble with the solvent, that is nothing but your insoluble solid, and that is represented by the B, component B, and its flow rate is represented by the capital N. Okay, I will explain that in the next slide. And third part is nothing but your consists of the soluble solutes, that is nothing but C. Okay, so first part is nothing but your pure solvent, that is component A. After that, insoluble solid means which is not soluble in the extracting solvent, that is component B, or I can say just insoluble solid. Last one is nothing but consists of the soluble solid part, that is nothing but component C. Okay, there is one thing more, that inert solid is nothing but your insoluble solid, means whatever the amount of the solid, okay, present in the initial stream, that is the same amount present in the final stream as well, or I can say outlet stream as well. Okay, so these are the nomenclature involved in the leaching process. Whenever we are going to take material balance, we are going to use these three components. Now we will see graphical representation of the equilibrium condition in leaching, or I can just say equilibrium diagram in leaching. So in this diagram, we are just going to plot N versus X or Y. So what is N? I told you in previous slide as well that N is nothing but flow rate of the insoluble, and X and Y, these are nothing but mole fraction of the solute in the gaseous phase and liquid phase. So you can see here. So in case of the leaching operation, equilibrium data are plotted on a rectangular coordinates with the N as the ordinate. Ordinate means that is nothing but y-axis, and X and Y as the abscissas. Abscissas means x-axis. Okay, means here we are going to plot one diagram, that is nothing but N versus X or Y. So N is nothing but flow rate for the insolubles, and X and Y, these are nothing but mole fraction of the solute in liquid and gas phase respectively. Now after that, I told you N is nothing but kg insoluble per kg solution, means this is nothing but flow rate for the insoluble. I told you in last lecture in absorption as well that whenever we are writing these mole fractions, we are writing this mole fraction on the free basis. Means here we are writing here B free basis, means whatever the B composition of the B, that we are not going to consider in our denominator. Okay, so this is nothing but weight fraction of the C in overflow, okay, on B free basis. So X is nothing but here the mole fraction of the solute which we want to extract from that solid, and Y is nothing but weight fraction of the C which we want to remove in the underflow. Underflow is not your required stream, okay, we are requiring here overflow stream. So we are also writing this Y in the B free basis, means whatever the amount of the fraction we are writing in the denominator, we are writing that in the B free basis, means we are not going to consider here mole fractions of the B. Now we will see how to draw this in the graph. Okay, so this is the figure for that, and this is the diagram. I can say this is the equilibrium diagram in the leaching. Okay, there are different types of the equilibrium diagram. I will explain those diagram in the next lecture, but before that you can just see here, this is the graph between N and X and Y. So N is nothing but, I told you that kg of the insoluble per kg of the solution, okay, and X and Y, these are the mole fraction of the solute which we want to remove from the solid in liquid and gaseous phase. Okay, after that upper curve is nothing but N versus Y, I can say that underflow. After that below curve, that is the MP, okay, that MNP is nothing but your overflow curve. I will explain this all things, means what is the meaning of this overflow curve, what is the meaning of this underflow curve. I will explain all this concept in the next lecture. This is all about this lecture. Thank you very much.